Have you ever looked up at the night sky and just wondered, really wondered about what's out there? Beyond the twinkling stars and the familiar face of the moon, the universe holds secrets so profound they challenge our very understanding of reality. And among the biggest, baddest, most baffling mysteries of them all is the black hole. It's a place where the rules we know, the laws of physics that govern our everyday lives, simply break down. Imagine a cosmic vacuum cleaner with an appetite so immense it can swallow entire stars, and not even light, the fastest thing in the universe, can escape its grasp. It's not just an object, it's a question mark hanging in the fabric of space-time. The story begins way back in 1783 with a man named John Michell. Michell was thinking about Isaac Newton's ideas of gravity and light. He asked a fascinating question. Could an object exist that was so massive and so dense that its gravity would be too strong for light to escape? Michell called these hypothetical objects dark stars. A few years later, the French mathematician Pierre-Simon Laplace independently came up with the same concept. In the 19th century, scientists discovered that light behaves as a wave, not just a particle. The idea of dark stars faded into obscurity, dismissed as a clever but incorrect thought experiment. That mind, of course, belonged to Albert Einstein. He turned our understanding of the universe upside down with his general theory of relativity. Imagine placing a heavy bowling ball on a stretchy rubber sheet. The ball creates a dip, a curve in the sheet. The sun's immense mass creates a huge curve in space-time, and the Earth is simply following that curve, what we call its orbit. A German physicist named Karl Schwarzschild was serving on the Russian front during World War I. He found the first exact solution to Einstein's complex equations. It showed that if you could compress that mass down to a certain critical size, now called the Schwarzschild radius, the curvature of spacetime would become infinite. At this critical boundary, spacetime would be so warped that it would effectively fold in on itself, creating a one-way membrane. The most common type, stellar mass black holes, are born from the death of the universe's biggest stars. Its core is a nuclear furnace, fusing lighter elements into heavier ones. For millions of years, the star exists in a delicate balance between this outward push of fusion and the inward crush of gravity. Eventually, the star runs out of fuel. With nothing left to hold it up, gravity wins, and it wins catastrophically. The core continues to shrink until its entire mass is compressed into an infinitely small point called a singularity. At this moment, a new black hole is born. Every black hole is surrounded by a mysterious, invisible boundary called the event horizon. Think of it as the edge of a waterfall in the river of spacetime. As you approach the event horizon, their view of you would seem to slow down. The gravity pulling on your feet would be so much stronger than the gravity pulling on your head that you would be stretched out like a piece of spaghetti. So, astronomers have to become cosmic detectives, looking for the clues and the gravitational footprints that a black hole leaves on its surroundings. One of the primary ways we hunt for stellar mass black holes is by watching how they affect a nearby companion star. Our X-ray telescopes in orbit around Earth can detect this unique signature. Supermassive black holes. These are the undisputed kings of their domains, gravitational tyrants that rule the hearts of galaxies. We call these incredibly bright galactic cores quasars. A quasar can be trillions of times brighter than our sun. One of the most spectacular phenomena associated with these active giants is the launching of colossal jets of particles and energy. One of the most common misconceptions is that black holes are cosmic vacuum cleaners, roaming the galaxy and sucking up everything in their path. This just isn't true. Another fun myth is the idea that black holes are wormholes or gateways to other dimensions or other parts of the universe. The legendary physicist Stephen Hawking made a stunning discovery in the 1970s. He showed that black holes should slowly leak radiation over time, a phenomenon now called Hawking radiation. So, we've journeyed from a dark star in the mind of an 18th century clergyman to the first real image of a black hole's shadow. Black holes are more than just cosmic oddities. They are fundamental to the story of our universe. They are the ultimate expression of gravity, the force that sculpts galaxies, forms stars, and holds our world together. Let that fill you with curiosity. The universe is under no obligation to make sense to us, and that's the fun of it. The cosmos awaits.